Module 2, problem number 13. The amount of time adults spend watching television is closely monitored by firms because this helps to determine advertising prices for commercials. Complete parts A through D. A, do you think the variable weekly time spent watching television would be normally distributed? This is one of those it could be, but let's think about it from a more logical standpoint. And remember, this is during the week, weekly time spent watching television. So it's not everyone has a lot of free time to watch 20, 30 hours. This is unlikely amount of time to watch television. Whereas a lot of people don't have that much spare time. They're at school, their kids are in activities, or they've got work, other family obligations. So it's very likely that you would see most of your data on the lower end of the spectrum, below the mean or gathered around the mean, where you're going to have a very thin tail on the higher end of the number of hours watching TV. So my gut tells me that it's not going to be normally distributed. So let's click no. Check. Fantastic. If not, what shape would you expect the variable to have? So first, we just talked about how it's probably not symmetric since we know it's not normally distributed, so it's not symmetric. It's not going to be uniform because that would mean you have the exact same amount of people or about the same amount of people that watch zero TV, 0 hours, 1 hour, 2 hours, all the way up to 30 or whatever the potential values could be. It's not going to be uniform. So we know it's either going to be skewed left or skewed right. So let's take a quick look from Module 1's lesson and look at the difference between skewed left and skewed right. So skewed left has a bulk of your data on the higher end of the spectrum right here, where the smaller tails here on the lower end. Now we already talked about that's really unlikely given that people are going to be watching television and it's going to be in their free time. We would expect the bulk of the data to be on the lower end, where the thinner tail is out here on the right. So we're going to say skewed right. Well done. All right. Now, according to a certain survey, adults spend 2.25 hours per day watching television on a weekday. So right there, we know our mean is going to be about 2.25, or our mean is 2.25. Assume that the standard deviation for time spent watching television on a weekday is 1.93 hours. So we're given our standard deviation. If a random sample of 50 adults is obtained, describe the sampling distribution of X bar, the mean amount of time spent watching television on a weekday. So now we also know that N is equal to 50. So first, one of the things that we learned about this week is how even if the original variable's distribution, in this case X, is not normally distributed, then the sample, that X bar, that is going to be normally distributed, especially the more number of observations you add to it. And we talked, I think it was 30, right? For central limit theorem, we're looking at over 30. So really quick, let's take a look at well, first, we already know that it's going to be approximately normal. So X bar is approximately normal. So remember, what is the mean of X bar and the standard deviation of X bar? Well, from the lesson this week, we know that the mean of X bar is equal to the mean of the population. In this case, it's 2.25. And the standard deviation of X bar is equal to the standard deviation of the population over the square root of N. The standard deviation we were given is 1.93. And the N, the number of observations or number of people in the sample, was 50. So let's do a quick calculation. And that's going to give us 1.93 divided by the square root of 50. That's going to give us 0.272943. So let's go put both of those numbers back into our problem over here and see. So X bar we know is 2.25 because that's the mean of the population. So the mean of X bar is the same. And this one we just calculate on the other page. Let's check our answer. Nice work. All right, now determine the probability that a random sample of 50 adults results in a mean time watching television on a weekday between 2 and 3 hours. So what that means is we're looking at the probability that this random variable X is between 2 and 3 hours. Now we know that just from looking at the distribution, that means that we're going to be looking at the probability of X less than 3 minus the probability of x less than 2. So remember, now the next step is to normalize this variable so that we can use a standard normal distribution table to look up those probabilities. So in order to convert those, we have to look at Z2 and Z1. So Z2, we're just going to assume is associated with the higher value. So here we're going to have x minus the mean of this x bar over the standard deviation of x bar. So we have 3, that's the value here, 3 minus 2.25 divided by that standard deviation we found up here, 0.272943. So just doing a little calculation, that gets us now in this case we only have to round to 2 decimal places because that's as far as the distribution table, that's the farthest it goes for accuracy in the table. So we have 2.75, and then for Z1, it's the same exact formula, except now we're looking at number 2. So we have x1 minus the mean of x bar over the standard deviation of x bar. So just putting that into the calculator, we have negative 0.92. So now we're going to take that and go to our standard normal distribution table. There's a couple places you can find this. One, you could Google it probably and just find it anywhere, but you can also access it from the back of the book. So when I'm working on these problems, I like to keep this table open in a separate tab just so that I'm not going back and forth a lot. So first, let's look for that probability of x less than 3, or the probability that z is less than 2.75. So we're going to have to go to the next page because that's going to be on the second page of the distribution table. You see how this one only goes to 0? Let's go to the next page. So we're looking for 2.75. So that means we start here by going down to 2.7. See, there's 2.7. If I can highlight it for you guys. 2.7. Then we're going to go over to 5. See how there's a 5 there at the top. So that right there is the area to the left of z equal to 2.75. And that gives us 0.9970. Now, the other part for x, or for z less than negative 0.92. So we're going to go back to the first page. So you see here on the first page, we're going to go down to negative 0.9. So you can see here. And we're going to go over to 2. Let me just double check. Yep, 2. So that is going to be 0.1788. So we're going to go back to our little work over here. So just to kind of link it back, here we had that probability of x being between 2 and 3 is the same as the probability that x is less than 3 minus the probability that x is less than 2. Here we converted. Now we come right back up here and pick up where we left off. So the probability that x is less than 3 minus the probability that x is less than 2 is equal to the probability that z is less than 2.75 minus the probability that z is less than negative 0.92. Now we just found those in the back, so we found out that this first probability was 0.9970, and this second probability was equal to 0.1788. So let's just put that into our calculator, 0.1788, and that gives us 0.8182. So let's go plug that back in to see if that's our probability. Let's go back to the homework. Check answer. Well done. So that's how you go, that's how you find that probability for that window in the middle between two values. So part D, one consequence of the popularity of the internet is that it is thought to reduce television watching. Suppose that a random sample of 45 individuals, so now we have n is equal to 45, who consider themselves to be avid internet users, results in a mean time of 1.86 hours watching television on a weekday. Determine the likelihood of obtaining a sample mean of 1.86 hours or less from a population whose mean is presumed to be 2.25. So in this case, we still have a mean is equal to 2.25. N is equal to 45. And let's go ahead and look at our sigma of x bar now. Our sigma of x bar, recall, is that sigma from the population, which in our case was 1.93, over the square root of n, which is square root of 45. So 1.93 over the square root of 45. So here we are with our 1.93 over the square root of 45. So let's plug that in. And that gives us about 0.287707. So that's our new standard deviation. So let's look at the rest of the problem. It says the likelihood is that, so remember, now we're looking for the probability that x is less than or equal to 1.86. So here's the probability we're looking for, and then we need to normalize it just like we did before. So here we have z is equal to x minus the mean of x bar over sigma x bar. In this case, our x is 1.86 from right here. Subtract 2.25 and then divide it by our standard deviation that we just found. So now we have, and again, we're only going to round to 2 decimal places for the table, that standard normal distribution table. So we have negative 1.36, just from rounding. So let's go back to our table. And I'll tell you right now, that is not going to be very likely because that's way to the left of the mean of 0. So let's look at negative 1.3, and then we're going to go all the way over to 6, which is 0.0869. Let's go back to the problem. 0.0869. Fantastic. So based on the results obtained, do you think avid internet users watch less television? Well, this is saying that the likelihood that they're watching less than 1.86 is very low, which is 0.08. That's not very likely. So I'm going to say I don't think that they watch less television. Well done. So that's how you do number 13. If you have any questions about it, let me know. I hope this helps you with any other questions you might have had on some of the other problems.